In this video, I will be explaining why the titration of a weak base with a strong acid forms a stoichiometric point with a pH that is slightly acidic. In this example, we will be using the weak base ammonia with a strong acid hydrochloric acid. So to observe, we will show the reaction of NH3 inside a solution. Ammonia forms ammonium and hydroxide ions. And now we will observe what a hydrochloric acid does in solution. It forms a chloride ion and creates hydronium ions. And so, at a stoichiometric point, you have equal amounts of the acid and the base, which also implies that there will be equal amounts of hydroxide and hydronium. Inside a solution, when hydronium meets hydroxide, it forms H2O. So when you combine these two equations, and ammonia is equal to hydrochloric acid, then these two become H2O, and there are no excess hydronium ions or hydroxide ions. This can be explained as the hydrogen ion from hydrochloric acid combines with the ammonia to form hydronium, leaving none to react with the water. This makes it so at stoichiometric point, the solution consists of only the salt ammonium chloride and H2O. Now notice that in this salt, chloride does not affect the pH, but ammonium is actually a weak conjugate acid. So one must take into account that ammonium is a weak conjugate acid and find the pH using that. So ammonium forms ammonia and hydronium ions. And as we discussed before, at the stoichiometric point, the initial amount is just 0. And the initial amount of ammonia, since it was completely neutralized by hydrochloric acid, is also 0. And you can disregard H2O since it's a liquid. And using that, by the end of this ice table, you should be able to get an amount of hydronium ions. Let's say that there was 1 mole at the beginning, or 1 mole concentration at the beginning. And when you find the Ka, eventually you find an amount of hydronium ions, and that creates a solution with a pH that is slightly acidic. Thank you. And that should be subtracted. But at the end, you will find a solution that has mostly hydronium ions and no hydroxide, which will create a slightly acidic solution. Thank you.